Hi guys, welcome back to another video. And in this video we're going to be writing a Lexer from scratch. So this video will be a start of a series of video in which we'll try to build a compiler from scratch. And the first part to building a compiler is a Lexer. A Lexer is basically a program that takes in a source file as an input and breaks that source file into a bunch of tokens, and the tokens are defined by some predefined logic. So this would be more clear when we make it practically. Creating a compiler, I believe, has three essential parts. The first part is the Lexer, second part is the parser, and the third part is generating the assembly. And the Lexer is the comparatively the easier part, and I find creating the parser to be a bit tricky, but creating the Lexer is probably the easiest part. So let's get started. So we're going to be calling this compiler pilot, and I'm going to be uploading all of the project things on GitHub, so you can also check it out if you want. And the extension of this language would be .py. So first of all, we make the directory. So mkdir pilot, and then we do cd pilot, and let's open this in VS Code. We have our empty directory open. So let's make the pilot.cpp file. I was first of all thinking to write this compiler in C, but that would be very much harder because we do not have built-in support for vectors or strings in C. So then I thought of writing this in C++. So let's first make a simple hello world file. And what I want to do is I want to configure the build task for this. So that's why I'm first writing a simple program. So we do stdc out hello there, and then we return 0. And now let's configure the build task. I think we do this from here. I don't think we need to change all of this. This is the we just need to supply the name of the file. That would be pilot.cpp, and the output would also be pilot.exe. I think we don't need the exe pilot, and we do not need the options and the problem match. I don't even know what they are. And the group should be the kind of the group should be build and should be default. And I think we are good to go. We need to put a comma over here. So let's save this and let's open the terminal and build this. So yeah, the build is successful. Now let's try to run this. So let's do pilot and hello there. So we have a basic program ready. So first of all, what you want to do is we want to define the syntax of our program. By the way, the extension for my language would be .py because I think pilot and .py. So it sounds good maybe, so I don't know. So first of all, let's define a basic simple .py file. So we'll call it example.py. And what I want is a language which is not statically typed. I want it to be dynamically typed. I think this would make stuff a bit more harder when we generate the assembly. But if I find that it's more harder, then I'll probably switch back to statically typed. But for now, let's just consider this language to be dynamically typed. So the way variables are declared in this language is we can either start that with an underscore or an alphabet, and after that we could use anything like we could use numbers, alphabets, or underscore. So for an example, this number 1 is equal to 141. So basically the name of the variable is equal to an integer literal, and then we end this off with the semicolon, and this is a valid statement. And let's do this. We start with a semicolon, start with an underscore, number underscore 2 is equal to, let's say, 27, and then we return number 1, let's say. So basically what a Lexer would do is we would define the base logic for a ID. So basically the name of the functions or the variables are called ID, and keywords like return or whatever else keywords we would have in this programming language, those would have a separate category. And 141 and 27, these are their own type. These are called integer literals. We could call them int, and the semicolon is of the token type semi. We could just wrap this around a parenthesis. So now we have two more tokens, the left parenthesis and the right parenthesis. So we need to define a token for each type. So what a Lexer would do basically is it would take in the source file, it would divide that source file. Basically we would supply this entire thing to the Lexer, and it would break it down into a bunch of tokens. So it wouldn't check whether this program is synthetic. It wouldn't check whether this program is the syntax of this program is right or wrong. So we could just essentially do this 141 is equal to number 1. So Alexa wouldn't raise any error over here because Alexa would only check for, it would check for tokens. It would find a integer token over here, an equals token over here. Sorry, an equals token over. I cannot select this. An equals token over here, an ID token over here, and a semicolon token over here. When we are writing the parser, we'll define the context tree grammar for it, and then over there we'll raise this issue. But over in the Lexer, we won't find any kind of error over here. But let's say we have an undefined token like this, undefined symbol like this. So when the Lexer will encounter this, the Lexer will raise an error. So we'll have an undefined symbol error in the Lexer, not syntax error over here. So both of these statements are valid for the Lexer, but for the parser, only this is valid, given that this is how we describe our CFG. So we'll save this. And now we need to take this command line input basically. So I'll just do int argc, I believe, and a double pointer to char and argv. And we'll just do if argc is less than 2, please supply the source file, and we just exit. And else, if we do not exit, that means we have supplied the source file. So I'll just write this for the sake of simplicity. It would be pilot example.py, and I'll also print it so it becomes a bit more verbose. So reading from the file name and now we just need to open this in an input file stream. So we'll just include this first. Oh, it's not if stream, it's f stream. So we'll just do std if stream source file stream, and we'll pass in the argv1 to it. So basically we're creating an input source file stream. And now let's create a string stream called as buffer that would basically store in the characters which we read off the input file stream, and then we'll ultimately convert the string stream to a string, and we'll call that the source code. So we'll just define std string stream buffer, and now we could just define a temporary character. It's giving an error for some reason. I think we need to import it. So that should fix it. And now we have a temporary character. And what we'll do is we'll do a while loop, and while source file stream dot get temp. That means while we are reading off the source file stream, we'll just push the data into the buffer. And then after all of this is done, we'll just create a string called as the source code, and which should be equal to buffer.str. And let's just print this out and let's see what's happening. Source code. So now let's save this and build this. And if we don't supply anything, it should raise an error. and let's apply the example.py, and there you go. This is the source code and we're reading this off. So we have a start now, and now what I want to define is the Lexer. So we'll make a separate folder for it. We're gonna keep things a bit clean, call as headers, and now let's create a Lexer, lexer.hpp, and we'll do the if and def basically. Like if this is not already defined, then only we include this to rule out the possibility of multiple inclusion problems basically. So Lexer, let's put this in caps. If not defined, then we define this, and we just end if. So now we have this. So now what I want to do is I want to create a class Lexer, and in the constructor of that class we'll pass in the source code, and that will have all the members that we are concerned with. So we'll do class Lexer, and okay, we don't put this over here, and we just make the constructor. So the constructor would not return anything, I believe. Yeah, the constructor won't return anything, so we'll just do a constructor, but it will take in the source code. So it would take in the source code. So, and we need to put this in the public block, and we also need to have the private block, which will have stuff like this, the source code. We could actually pass the source code as a pointer, but let's just keep things simple for now. So we'll have a string source, and we need to include string, I believe. So I think this should take care of it. Yeah. So we'll have a string source, then we'll have an int cursor, I believe. This would basically be a pointer to the source. We'll have basically the index of the source, and then we'll have a int size. So, and we also have a character current, which would basically hold the current character to which the cursor is pointing at. So we'll have a character current. So now when we pass the source code, basically the source should be equal to the source code, and why is this raising an error? Okay, and the cursor should be equal to 0. We'll start from the start of the 0th position, or the start of the file. And the size should be equal to source code dot length, and the current should be equal to source code dot at cursor. So now we have our basic constructor class ready. So let's save this. Let's include this in our pilot.cpp. Lexer.hpp. Let's save this. And why is this showing an error over here? Expected okay, we need to put this over here, I believe. Okay, yeah. And then include lexer.hpp, and now let's create let's have basically, this is the end of the program. So basically we'll keep a track of the end of the program, and over here now let's create a Lexer class. So I think it was in capital, yeah. So Lexer, and we pass in the source code. So let's see if this is working or not. Let's try to build this. Okay, there has been some error. Okay, we need this has to be in headers /lexer.hpp. So now let's try to build this again, and the build has finished successfully. Now if we run this, okay, so we are getting to the end of the program. So I'll just do another end line over here. The end line should have been here, but anyways. So now we have our Lexer ready. So basically we need to first define some basic functions over here. So we'll define a peak and an advance function. The peak function would basically take in an offset and it would return the character at that offset. And the advance function would basically advance our cursor. So the advance function should be a void, I believe. So void advance. And I don't think we need to give it any kind of parameter. I think we'll always advance by 1. So we'll do if the size is less than, sorry, if the cursor is less than the size, we'll declare a temporary character, I believe. Okay, we'll just make it a character also, because when we call the advance function, so when we call the advance function, it would okay, so when we call the advance function, it would return the character at that position, and then it would move forward. So it would, let's just hold the character in a temporary array. Let's just hold the character in a temporary variable. So char temp is equal to current, and then we'll just increment the value of the cursor. So the cursor plus plus, and we'll just make a check over here. If or we could just do this, current is equal to, if the cursor is less than the size, then it would be source cursor, else we'll just write it out EOF, or basically 0. Else also we would return an EOF. So I think our advanced function is ready. Now we need to have a peak function. So character peak, it would take an offset. I think it should default to 0. And if we need to check whether the cursor plus the offset is in the bounds of the source code or not. So if cursor plus offset is less than the size, then we will return the source cursor plus offset, else we will return the null character. So now let's define our token. So we'll do struct token, and let's first do a enum token type, I believe. Enum type. First it could be an ID, or basically we'll write the definitions of our token over here. So it could be an ID, it could be let's not make a separate token for keywords now, to make things simple. It could be integer, it could be equals, and it could be a semicolon, and it could be an open bracket or a closed bracket. So token, let's do left parenthesis, token right parenthesis. So the struct token would have, so we have our enum type, and the struct token would have an enum type called as type, and it would also have a string value. So now let's create the main tokenized function. So the tokenize function is basically, we'll call it from here. So once we declare the Lexer, we'll just call basically the tokenize function would tokenize the source code and return a bunch of tokens. It would return pointers to the token. So what we need to do is std vector pointer to token, and we call this tokens, and this should be Lexer dot tokenize. So basically, when we tokenize this, it would return a pointer to a bunch of tokens, and we need to include vector, I believe, and we need to save this. That's why. And we need to define the tokenize function here. So it would return a vector of pointers to token, and we'll call it tokenize. So first of all, we define the vector. We need to include the vector also over here. Then we define the vector. So std vector type token pointers, we call this as tokens, and then we define basically another token which would hold the temporary tokens. And what we'll do is, while we'll have two terminating conditions. So while the size is less than, while the cursor is less than the size, and we're not at the end of file. So basically this would be a boolean. Not end of file would be a boolean which would show us whether we are at the end of the file or not. So not at the end of file should be equal to true for now. So while the cursor is less than the size and we're not at the end of file, so first of all we need to skip any kind of new line or return characters or spaces. So we'll write check and skip. So we need to define this function also. So this would be a void function, check and skip. So while our current is equal to a space, or current is equal to new line, or current is equal to a tab, or current is equal to a return character, I believe. We'll just advance. So we need to check and skip. And if so, now we define the logic for ID. So the ID can start with a alphabet or an underscore, but it can also start with a digit. So if you find anything starting with an underscore or alphabet, we will try to classify that as an ID. So if is alpha current, or current is equal to underscore, then we'll define a function called as tokenize ID, and then we'll continue. So we need to define the function tokenize ID, and tokenize ID would be it would return a pointer to token. So we store it in the temporary token variable which we had made. Or I don't think we need this. We could just remove this and we could just do tokens dot pushback, and we push back whatever is returned by the tokenize ID function. So tokenize ID. So we define the tokenize ID function. So it would return a pointer to token, and we'll call this tokenize ID. So basically, since we are inside the tokenize ID function, that means this was true. That means the current is either an alphabet or an underscore. So we could just define a string stream over here also, call this as buffer, and we could just write the advanced function to it. So if we need to again import this string stream. I don't know why I keep saying import. It should be include. I think this is how we do it, right? Yes. So yeah. So if you don't remember, the advanced function would return a character. It would basically return the character to which the cursor is currently pointing to, and then it would advance the cursor depending on some if-else cases. So we'll the character is returned over here, and we'll just inject that character into our string stream. So the first character was an alphabet or an underscore, so that would go over here, and we'll just do another. How do we do this now? Let's create a temporary character, I believe, and while temp. Let's see how do we do this. Okay, we don't need to do this. We don't need to create this. We just need to check the status of the current. So now that the first character is injected into the string stream, now the variable can have an underscore, an alphabet, or a digit. So we'll do is alnum current, or current is equal to an underscore. If that's the case, we again inject that to our. I can never type when I'm speaking. So if that's the case, we'll inject this to our buffer string stream called buffer. And while this is happening, so basically this would contain the buffer. The buffer would contain the name of the entire variable or the function name, basically the ID. And now we would create a new token. So token new token is equal to new token. Just another thing which I wanted to mention over here is I was making this project a while ago before shooting the video, and instead of using a new token, I was using malloc over here. I don't know for why. I really like the style of malloc, so I was using malloc 1 into size of struct token. So I was doing this. So please do not do this, because after like debugging this for an hour, I found out that when we use the C style malloc, it basically has no built-in support for string or something. So it's just something which I wanted to share. So just don't use this. So we'll create a new token, and the new token will have a type of token ID. Since this would be an ID, we are tokenizing an ID over here. And the new token value would be equal to buffer to str. Remember, this is a string stream, not a string, so we need to convert this back to a string, and we'll just return the new token. So our tokenized ID function should work now. So basically, I'm returning a pointer to a token, and then we're pushing that back, and then we'll do continue. So this is the logic for IDs. This is the logic for IDs. Now we need to define the logic for int literals. So if is digit current, this is the logic for integer literals. Then what we'll do is we'll just do tokens dot pushback tokenize int. So we need to create this, and we'll also do continue. So we have to create this function tokenize int, which would again return a pointer to a token. So token star tokenize int, and we could just make a string stream over here, just like we did in the previous tokenize ID function. Buffer, and while is digit current. So we'll just inject this, and then again it's like very similar. We create a new token, and the new token type would be equal to token int, and the new token value would be equal to buffer.str, and then we return the new token. So the is alpha, or the logic for IDs is working, integer is working. What else do we need to write for? Okay, so now we could just do a switch case to check for equals and semicolon and open and close brackets. So we could just do switch. Okay, we could just do switch current. Let's write for case semicolon. So what we'll do then is we would let's do okay, let's do tokens dot pushback, and we'll call this the tokenize special, I believe, and we'll pass in the ID. So token, and this would be the semicolon, and then we'll break. So why is this giving me an error over here? Oh, that's why. Okay, so now we have this. We need to define this, of course, but for now let's just copy this and paste this. So for semicolon, open bracket, close bracket, and an equals to. So equals to token equals left bracket, left parenthesis, right parenthesis, and semicolon. I think we did for semicolon, yeah. And if we do not reach anything, then the default case would be I think we'll throw up an error over here. So we'll just do stdc out, and we'll just do, let's put this in caps, parser error unidentified symbol, and we just write this to the screen. So we'll write the current to the screen, and we'll just exit. And we need to include the IO stream since we are printing. So let's save this, and I think this should be working. I think so. So let's try to run this. Oh, we didn't even define the tokenize special function. So let's define this. So tokenize special. So basically we create, in a similar way, we create a token, and we'll take in the enum type called as type, and the token, we just create a new node, token new token is equal to new token, and the type of the new token should be type, and the value of the new token should be advance, I believe. But the thing is, advance would return a string, and advance would return a character, but the value is defined as a string. So what we could do is we could use a string constructor over here, and just we could specify the length of the string and the character. So I think this should work. Okay, we need to maybe do this. and we'll return the new token. So I think this should be a working Lexer, but I haven't built this program yet. So let's see even if we reach the end of the program or not. Let's see if this crashes or not. Try to build this. So it's built successfully, but let's see what's happening. So we do reach the end of the program. So that's nice to see. So now let's just loop through the tokens. Let's see what we are getting. So we could just do for token pointer temp in tokens. Is this how we do it? Okay. How did we do it? Oh, I think it's not this. It's semicolon. Yeah. We'll do stdc out, and we just need a counter also. And we'll just do we increment the counter first, and we'll just print the counter. So counter, and then first let's just format this properly, and then we write the type first. Let's do the type first. Type and a little bit of space, and then we'll do the value, and we do it every time we do it in a new line. So let's save this, and now let's build this. Now let's run this, and first let me clear the screen. Okay. I think there is some issue over here. So it turns out that we were not returning the tokens vector which we had created over here. So we just do return tokens, and let's just loop over this again. So we'll just do for temp and tokens, we'll increase the counter. I believe this should work. Counter, and then we do the type, I believe, first. Let's do the value first, and a bit of space, and then we do the type. So now let's try to build this, and I think I also need to write an end of file token, but if it works out this way, then I don't think I would need to write it. So let's try to build this, and let's see what's happened. So we are getting some kind of errors. I think there is something wrong with the advanced function. Oh, we're not even returning anything. Wow. So let's build this. Now let's run this. Let's clear it first. And there you go. It's kind of working. I think it's working properly now. So number 1 should be of type 0. I think we need to create a function which would take in the type and return the string. Something like I don't know, type to string. So we need to define it over here. So it would return a string to, and it would take in the enum type as an input, and we'll just do a switch case. Switch the type. So case, and I don't think we need to put a semicolon over here. So the case for token equals, we return equals, or let's do it in caps, or let's just copy and paste this, and we need to write for 6, I believe, 5 more cases. 1 2 3 4 5 token int. So case token int, we'll return a token int, token equals, okay, not token equals, okay, we didn't define token ID first. Token ID, token int, token equals, token semicolon, token left, and token left and token right parenthesis. Let's do a default. I don't think we need a default over here. I think this should be working. Yeah. So now let's why is it undefined now that we have defined this type to string? Okay, let's just do type to string, and now let's build this, and let's run this again. So yes, we are getting number 1 is of token ID, then we have an equals token, then we have 141, then we have a semicolon, then we have token ID number, this is also a token ID, then an equals, then 27, then semicolon, then another token ID, then left parenthesis, then number 1 is a token ID, and then the right parenthesis, then the semicolon. So now even if we do something like number 2, this is obviously, like, from the point of view of syntax analysis, this is an error, but our tokenizer would not generate an error. So if we run this, there you go, this classifies as a token ID. But if we write an undefined token like this, it should raise an error. So let's see what's happening. Parse error, unidentified, indentified. Okay, there has been some spelling mistakes. So unidentified symbol and current. Okay, so let's save this, let's build this, let's run it again. Yep, it's working. And what I want to do is I want to mention the position, the line number, and the position at which this error has happened. So let's create 2 more new private variables, int line number, int character number, and in the constructor, where is the constructor? The line number should be 1, and the character number should also be 1, because we're reading the first line and the first character. And I think in the check and skip, if we encounter a new line, so if current is equal to, we write another if is equal to new line, then what we'll do is we'll increment the line number, and the character number would be 1. Else we'll just increment the character number. This should be working, and we'll just write over here in our error display message, line number, let's put a semicolon over here, and character number. Even though we are exiting, I just like to put a new line. So this should display our error message properly. So now let's build this, let's run this. And I had to do this, okay. I had to specify a new line over here. Let's build this. Okay, so line number 1 and character number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it shouldn't be character number 2. So there is some issue in the way we are incrementing the character, I believe. Okay, I got I think if the character is a new line, then we increment this. Let's just make this 0, and over here we'll do character number plus plus. Let's see what's happening. I think it's working now. 1, 2, 3, 4, 5, 6, 7, 8, 9, ninth character. And if we save this, this should give us no error. Okay, let's just display a message over here. It should be tokenized successfully. Okay, we forgot to build this again. So tokenized successfully, and we have our tokens over here. But if we like write an undefined symbol, let's say we write this over here in a new line, let's say an asterisk symbol. So we receive a parser error in line number 3 and character number 1. And let's just do this over here. Let's just do I don't know, let's just do a question mark over here. And if we run this, line number 2, character number 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, no, 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah. So line number 2 and character number 11. And if we remove this, this should work again. Tokenize successfully. Let's just try to do a bunch of different stuff like this to basically see if our logic of variable is working properly or not. So this is also a proper token ID, and if I do this, let's just get rid of everything, just this. This should also be a proper, this should also be a token ID, yeah. So our Lexer is now properly working. So the next video we'll try to make a parser, which would be a bit more trickier than this. We would need to define a context-free grammar for it, and then we would write a simple parser. So thanks for watching this video. I'll upload this entire project on GitHub, so you can check it out if you want. And yeah, thanks for watching.